morning dear students. Welcome to Akshat International School online classes. In the previous videos we had studied a lot of image formation and the properties of images and everything. Okay? But the today's class is very important for the numericals. Okay? We will see something very important which is very useful in numericals. Fine? Okay? So today's class is completely dedicated to the numericals. Fine? So see it with full concentration. Okay? Note all the points which I am discussing today. Okay? Fine? So image formations we had studied in the spherical mirrors as well as in a plane mirror also. Okay, so there are 6 cases, 6 different positions in a concave mirror where we keep the object, and 2 different positions in a convex mirror. Okay, in a concave mirror, the image formed is real also and virtual also. In one case, the image is formed virtual, and in other 5 cases, the image is formed real. Okay, and in a convex mirror, in both the cases, the image formed is a virtual image. Fine? Okay, we'll see the uses of these mirrors according to their image formation. That also see, but in the next video. But in this video, we are going to study about the 2 very important formulas. Okay, first is the mirror formula. And second is the magnification. Okay, second we'll see the magnification. It also has a formula, that is magnification. And every year, almost every year, CBSE is asking a question on magnification, or say the combination of these 2 terms which I had written here. Okay, so let's see one by one. First, I am going to explain you all about magnification, and then we'll move to mirror formula. Okay, so basically magnification is a term which we have to define it. It is a kind of physical quantity, we can say. Okay, because we used to measure the size of, or I can say we used to compare the size of image with respect to the size of object. Okay, that means if the height of the object is say HO, then with respect to this height, what will be the height of the image? Whether the image is magnified or the image is diminished, means smaller than the size of the object. Okay, this can be verified, or this can be seen by using or by just getting the information about the magnification. Then what is the magnification in case of any of the numerical or any of the image formation. Okay, so magnification is the ratio of height of image with respect to height of object. Okay, in many books this initials are not used, but they use H1, H2 or HH dash, which is little bit confusing. But what I am using here, I am using the initial of image, that is I, and initial of object, that is O. Okay, so it is easy to learn the formula that M is equals to HI by HO. Fine, where HI represents the height of the image, HO represents the height of the object. So basically this is a kind of comparison that with respect to height of object, what is the height of the image. Okay, so what is magnification? Suppose in exam it comes directly like, what is magnification? Write its formula. or write its numerical value, numerical representation, sorry. Fine. So defining magnification, like it is the ratio of height of image with respect to height of object, that is m equals to hi by ho. Fine. So this we have to learn today. I hope you got it. Okay. This is a simple formula, m equal to hi by ho. But this I am not going to mean. I am not talking about this one, that this is very important. This is a simple formula and anybody can learn this. Fine. But what I am discussing, or what I want to discuss, is that if the magnification of the image is given, then in that case, how can we identify that the image formed is a real image, a virtual image, an enlarged image, or a diminished image? Just by looking the given magnification, the numeric value of magnification, just by looking that, we can find out the image formed is a real image or a virtual image. Just by looking that formula, sorry, the numerical value, we can find out the image is an erect image or an inverted image. Okay, image is diminished or image is enlarged. That all we can find out by just seeing the numeric value of magnification. Okay, so we are going to discuss some standard points related to magnification. Okay, now let's see that suppose m is given positive. I am discussing standard points. Okay, it is for like everyone. Okay, and suppose m is given positive, a positive value, a +1, a +2, a +1/2, or say +1/3, 1/4. If the m, that is magnification, is given positive, then one thing is sure, that the image is virtual and erect. The image is virtual and erect if m is given positive. Okay, now whatever points I am discussing, be careful. Whatever points I am discussing on the basis of the syllabus which is given in class 10th. Okay, maybe possible in class 12th there will be some little bit of difference here and there. Okay, but as per your 10th class syllabus, whatever I am discussing, that is very important. Okay, say m is given positive, then 100% we will say that image is virtual and erect if m is given positive. If m is given negative, okay, then in this case the image will be real and inverted. Means the image formed will be real image and it will be inverted image. Okay, now let's find out with an example. Okay, suppose, I hope you noted down that what I had written here, that if m is positive, image is virtual and erect, and if m is negative, then image is real and inverted. Okay, now let me take concave mirror, because in this mirror both type of images are formed. Okay, I hope you all remember the sign conventions that we had studied. Okay, now suppose the object is kept beyond C, that is beyond center of curvature, then the image formed is between center of curvature and focus, if you remember this. Okay, when the object is kept beyond center of curvature, the image formed is between center of curvature and focus. Okay, now as we know that the magnification is the ratio of height of image with respect to height of object. Okay, and here we are only seeing the sign of m. If m is negative, then image is real and inverted, and vice versa. Okay, that means if image is real and inverted, that in that case m will be negative. Okay, so let's see it here. By sign convention we can see that height of the object is, that means object is kept above the principal axis, over the principal axis. That means the HO is positive because all the calculation about the principal axis are taken positive. Okay, so if I have to mention the sign, then I'll write plus HO. Okay, and the image which is formed, that is an inverted image, and if it is inverted then it will be below the principal axis, so we take it negative. So here the image formed is negative, that is minus hi by ho. Now doing little bit of math, we can find out that this can be written as minus of whatever जो भी है यहाँ पर. Fine. So this negative sign automatically comes when the image is real and inverted. Okay. So from this we can conclude that if the image is real and inverted, then your magnification will be negative. Or if the magnification is negative, the image which is formed is real and inverted. Okay. Similarly, for the virtual image, let's see for virtual image. Now this is the only case that when object is kept between pole and focus. This is the only case in which the image formed is virtual and erect. Right now we are not discussing the size or height of the image, but we are discussing about the negative and positive. That is, when m is given negative, in that case what will happen, or if m is given positive, in that case which type of image is formed. We are not discussing whether the image is enlarged or diminished. Okay, just we are discussing first about the sign convention. Fine. Now in this case, from here you can see that if I have to find out the magnification in this case, then this is HO and this is HI. Okay, now you see object is always kept upright over the principal axis, so plus HO. Okay, let's, as this is HI and this is HO. Fine. Now here also, sorry for this. Okay, this is ratio of height of image with respect to height of object. Here also, say this is HI, which is positive. Okay, and this is HO, again this will be positive. So in this case also M is positive. Now if we see that if the image is virtual and erect, then M will come positive. In any of the cases, whether you take the convex mirror, in convex mirror also, in both the cases the image is formed behind the mirror, and if it is formed behind the mirror above the principal axis, we can say that the height will be taken as positive. And object, as I said, object is always kept above the principal axis, so it is always taken positive. Okay, so by using the formula, that is Hi by HO, by using the formula that is Hi by HO, okay, we can find out that height of the image in this case is negative and height of the object is, like as I said, it is always positive. Fine. So M is minus Hi by HO. The overall calculation will be negative. Here M is plus Hi by plus HO. The overall calculation will be positive. Okay, so if M is given negative, then image will be real and inverted, and if M is given positive, then image will be virtual and erect. Okay, now let's come for the next part, that is whether the image is enlarged or diminished. Okay, how can we find out that thing? Okay, now as we know that M is Hi by HO, this is the formula. Okay, now suppose M is given greater than 1, that is greater than unity. Now this ratio, that is m, is hi by ho. In this one, this will be greater than 1 only and only in one condition, when the numerator will be greater than the denominator. Okay, if the numerator is greater than the denominator, the overall fraction will be greater than 1. We know that, isn't it? So, if m is given greater than 1, then we will say that the height of the image is more than the height of the object. That means the image is enlarged image as compared to the object. Fine? M is hi by ho. M will be greater than 1 only and only in that condition when hi will be more than ho. That means the height of the image will be more than the height of the object. Okay? Now, what if m is given less than 1? Achha, greater than 1 means like m is given plus 2. Okay, now what you tell about this one? If m is given plus 2. Now, if m is given plus 2, that means the image formed is a virtual and erect and magnified. Why I said virtual and erect? Because it is given positive. Why I said enlarged image? Because it is greater than 1. So we will say that the image formed will be virtual and erect in this condition. Virtual and erect, enlarged. Okay? Now, what if m is given less than 1? If m is less than 1. Now, from math you can see that this will be less than 1 only and only when the numerator is smaller than the denominator. Then only this overall fraction will become less than 1. Okay, now this overall fraction will become less than 1. That means if suppose m is given minus 1 by 2. Okay, now if it is given minus 1 by 2, that means first thing that minus sign represents the real and inverted part of the image, and 1 by 2, as it is less than 1, it represents the image is diminished. That means the image formed is real and inverted, smaller than the size of the object. This is what given here. So just by seeing the sign and the numerical value of m, we can find out that whether the image is enlarged, image is diminished, image is virtual and erect, or image is real and inverted. Okay? Then the third case, this is say the first one, say this is the second one. What if m is equal to 1? Okay, now m will be equal to 1 in one and only one case, when the numerator is equal to the denominator of the object. Fine? Means denominator in the fraction. If they both are equal, then we can say that m will be equal to 1. Fine? Now, if m is given 1, that means the height of the image is equal to height of the object. Okay, and we have only two mirrors which represents this condition. One is your plane mirror, that means m is always plus 1 for a plane mirror. Why plus 1? Because the size of the object is always equal, the image size of the image is always equal to size of the object, and it is always virtual and erect. So if given m is plus 1, that means the image formed is virtual and erect, equal to the size of the object. As I said, there are two mirrors. So second mirror is the concave mirror. In that, there is a case in which when object is kept at center of curvature, image is formed at center of curvature equal to the size of the object. That means if it is given m is equals to minus 1, that means it is representing that case in which the object is kept at center of curvature in a concave mirror. Okay, I hope you got this point. Fine. One more time, let's discuss that if m is negative, if m is given negative, image formed as real and inverted, vice versa. If m is positive, the image formed is virtual and erect, vice versa. If m is greater than 1, the image formed is enlarged image. The size of the image is more than the size of the object. If m is smaller than 1, that means the size of the image is smaller than the size of the object. And if m equal to 1, that means the size of the image and the size of the object, they both are equal. Fine. So in numericals, it is asked that the image formed is 1/4 the size of the object. Now this 1/4, they will not give you that the magnification in this case is 1/4, but they will tell you that the size of the image is 1/4 the size of the object, and the image formed is a real image. Now if it is said that image formed is a real image and the size of the image is 1/4, then you will write m is equals to -1/4. Okay, this is the condition. So I will provide you some worksheets in which numericals are there. We will solve the numericals and we will find out how to do such kind of questions. But the concept is clear. Okay, now let's come to the next topic. As I said that we'll discuss about the mirror formula. Okay, in this mirror formula there is nothing to explain. The derivation of this mirror formula is not in our syllabus. Okay, this you will study in class 12th. Okay, that 1 by f is equals to 1 by v plus 1 by u. Okay, let's see that what these symbols mean, meaning of these symbols. I hope you know that f is the focal length of the mirror which we are using. V is the distance of image. V is the distance of image from mirror. Okay, or we can say from pole. Okay, and u is the distance of object from the mirror. This is the distance of object from the mirror. Okay, so we'll have this formula, and using this formula we are going to find out many positions of the object, positions of the image, and as well as we can also find the focal length of the mirror. Okay, it depends that what is given in the numerical. We will see the data in the numerical. We will note down their signs first of all, that whether the given mirror is a concave mirror. If it is a concave mirror, then the focal length will be negative, because the focus of a concave mirror is towards the left side of the mirror. Fine. So we will say that the f will be negative in a concave mirror, f will be positive in a convex mirror. Convex mirror, the focus is virtual, which is behind the mirror, that is towards the positive side. So f will be positive in convex mirror. These are the facts actually. Okay, in case of convex mirror, V is always positive. Why? Because there are only two cases, and in both the cases the image is formed behind the mirror, and if it is behind the mirror, that means it is positive. Okay, in a concave mirror there is only one condition in which the image formed is a virtual image. That means in case of a concave mirror, V can be positive or negative. Okay, in case of concave mirror or a convex mirror, U will be negative. Why? Because object we keep always towards the left side in most of the cases, theoretically at least. okay, towards the left side, so u will be taken as negative. Fine. So these signs we have to be very careful. On these signs we have to be very careful. Okay, that whether we are going to take it positive or negative. If you are not able to solve the numericals in physics in class 10th light reflection, then the only problem is that you are not thorough with the sign. Okay, and that you have to learn. From this video you can find out, you can solve with the help of this video you can solve the numericals. Fine. I'll provide you a worksheet with this one so that it will be helpful for you. Okay. In next lecture, we'll do some numericals based on this one, and then we'll move on to the next phenomenon, that is refraction of light. Okay. That's all for today's class. Thank you.